All right, good afternoon, Calc 2 people. So we are going to talk more about some arc lengths. That's what we're talking about today. And let's go ahead and start recording. Oh, I already am recording. Okay, and let's go ahead and I'm screen sharing too. Okay, we are all set. Let's put this down, put this up. All right, so let's go ahead and take a look at a problem. This one looked fun, right? A hawk flying at 11 meters per second. Altitude of 132 meters, at least they gave us the same units, accidentally drops its prey, and the parabolic trajectory of the falling prey is described by the equation y is equal to this horrible thing, okay, 132 minus x squared over 33, until it hits the ground, where y is the height above the ground and x is the horizontal distance traveled. Calculate the distance traveled by the prey from the time it is dropped to the time it hits the ground. Okay, so let's go ahead and take a look at what's going on here. Okay, so the first thing we got to do is figure out, like, where does it hit the ground? All right, so what do we have here? We have y is equal, right, to 132 minus x squared over 33. So we're going to set y equal to 0, solve for x. All right, so we have 0 is equal to 132 minus x squared over 33. We're going to say something clever like x squared over 33 is equal to 132. And then we're going to be able to say that x squared is equal to 33 times 132. Now, here's something I noticed. X squared is equal to 132 is 10 or 11 times 12. So this is 3 times 11. And 12 is equal to 3 times 4, or 2 squared. Okay, oh, this is 11 times 12. So we could say that x squared is equal, right, to 3 squared times 11 squared times 2 squared, which means x is equal to 3 times 11 times 2, which is 66. All right, so we're going to go from 0 to 66. So x is going to go from x equals 0 to x equals 66. All right, so the next thing we got to do is we have y is equal to, again, 132 minus x squared over 33. And we have to figure out what y prime is. Okay, y prime is equal to negative 2x over 33. And then we need y prime squared, which is going to be 4x squared over 33 squared. I don't want to do that just yet. I know. That's my little girl there. She's a heart condition, so she cannot get anesthetic to go into heat. So we have to suffer. Okay. So what we're going to do is integrate, and we have the square root of 1 plus y prime squared. So 4x squared over 33 squared. All right, dx. And we're going from 0 to 66. Well, let's see if this helps. So we have 33 squared plus 4x squared all over 33 squared from 0 to 66, and this is the square root. And it helped a little bit, not much, right? But this is going to be 1 over 33. Wait a minute, no, we're good. Okay. And 0 to 66, so the square root. This puts it all on one level, right? Because we could pull out, oh no, we can't. No, we can just pull out this one. This is not 33, hold on. 33 squared here, dx. Okay. Well, there's no u, right? The u, if I pick a u, I need a du, which we need an x out here, and I don't have one. So if only there's some way to solve integrals that were inside of square roots that kind of look like triangles. Well, I guess we'll never know. Oh, wait. We could do this, couldn't we? We could say theta is here. We could say this one's 33. This is 2x, and this is going to be the square root of 4x squared plus 33 squared, right? Because we go ahead and get that. That means the tangent of theta is equal to 2x over 33. So x is equal to 33 over 2, tangent of theta. Great. Dx is equal to 33 over 2. Derivative of tangent is secant squared d theta. All right. Now, I'm just going to work with indefinite integrals because technically I should change all of the limits to this stuff to something else, but I don't want to do that just yet. So we'll backtrack it all the way into x's. Okay, so we're going to just work the indefinite case for now. Okay, so what do we have here? Well, we have the, right, we have this, well, let's go ahead and do it the way your book likes to do it. So we've got the integral of the square root, right, of 33 squared plus 4 divided by 33 over 2 tangent theta squared, because that's x squared, right? This is x squared. And this is what we have here. And then instead of dx, we're going to have 33 over 2 secant squared theta, d theta. There's a 1 over 33 out in front here. So fortunately, right, this and this can cancel. So we are going to be set with integral of 33, square root of 33 squared plus, you see that this 4 and this 2 also cancel here. Right? This 2 squared and 4 will also cancel. All right. So we're going to have plus 33 squared, tangent squared, and then this is 1/2. 2 comes out front. Secant squared theta, d theta. All right. Looking pretty good so far. So let's pull the 33 squared out of the square root. So we have 33 over 2 integral. We have the square root 1 plus tangent squared, secant squared d theta. Well, if we come over here, we can remember that tangent squared plus 1 is equal to secant squared. Hey, we've got a tangent squared plus 1 right there. That looks like secant squared. So we've got 33, 2, and then we have the square root of secant squared times secant squared d theta. And unfortunately, this is one of the more delightful integrals you are ever going to have to meet, which is secant cubed theta d theta. Okay. Or this is also secant theta times secant squared theta d theta. All right. So let me just do a little piece over here. We're just going to write down that we have 33 over 2 integral of secant cubed theta equals. And we're going to work off to the side here. So this whole thing is a sidebar, where we're just going to evaluate integral of secant cubed theta, d theta, d theta. Okay, so we're going to say that this is the integral of secant theta, secant squared theta. So now we could say something clever like u is equal to secant theta, du, or dv rather, is equal to secant squared theta, right? This is integration by parts. Okay, so I missed integration by parts. I wonder when it was going to come back. What's the integral of secant squared, right? Is that a tangent? Okay, so this is going to be secant theta. Right, this is going to be secant theta tangent theta minus the integral of secant theta tangent theta times tangent theta d theta. So this thing is equal. So we still have, right, this is integral of secant cube theta equals all of this. Secant cube theta equals secant theta tangent theta minus, and then we have integral of secant theta tangent squared theta d theta. Well, that looks a little familiar. Right, if I take tangent theta minus, or tangent squared theta is equal to secant squared minus 1. So we have integral secant cube theta is equal to, okay, secant theta tangent theta minus integral secant theta secant squared theta minus 1 d theta. So that's secant theta tangent theta minus integral secant cube theta minus secant theta. I'd almost not be happy, except that the left-hand side that's secant cubed, because this does not look pleasant, does it? So let's just break this apart. Okay, so we have secant theta tangent theta minus the integral of secant cubed theta minus or minuses plus the integral of secant theta. This is d theta, this is d theta, so d theta, d theta. And this equals integral of secant cube theta d theta. Okay. I'll bet we could add secant cube theta to both sides. All right. So here we have two integral secant cube theta d thetas is equal to secant theta tangent theta plus the integral of secant theta d theta. And this is an integral you're allowed to memorize, okay? Do you remember, if you wanted to actually do it, we'd have that, okay? And if we multiply this, we let u equal secant theta plus tangent theta, then du happen to be secant squared theta plus secant tangent theta. Okay. So that was a trick. That was how you integrate this thing. Okay, nobody is expecting you to memorize this, all right? But this is going to be 2 secant cube theta d theta, that's equal to secant theta tangent theta plus, and this is the natural log of secant theta plus tangent theta. Okay, so secant cube theta is equal to 1/2 the average, right, of secant theta tangent theta plus natural log secant theta plus tangent theta. Right. So what we have here, really we have the derivative of secant and the integral of secant. So it's the average of the derivative and the integral. Okay, it's really the easiest way, I think, to remember it. Okay, but delightful that it is. Okay, so there's our result. We're going to go all the way back up to here and say that 32 halves or 33 halves of the integral of secant cube theta d theta, this is equal to 33 fourths, right? Because it's a half times 33 over 2 of secant theta tangent theta plus ln secant theta plus tangent theta. Aren't you glad that you know how to do triangular integration and integration by parts now? I'll bet you are. All right, let's look at that triangle again. Okay, because theta was equal to, this is 2x, this is 33, this is the this is x, this is 4x squared plus 33 squared. Okay, so what's secant? All right, when we go back to all of this, we have 33 fourths secant, right? Hypotenuse over adjacent. So that's going to be 4x squared plus 33 squared square root all over 33. Okay, tangent 2x over 33. Right, plus natural log. This is going to be all positive because it's square roots and it's, we're going, x is going from 0 to 66. So these are all positives. You don't need an absolute value. But again, secant is going to be 4x squared plus 33 squared all over 33 plus tangent 2x over 33. All right. So there we go. Now we only have to do, this is the hard part, which is evaluating it from 0 to 66, now that we're back in the x world. Okay. Yeah. Okay. So we have 33 over 4 times this huge mess. Okay. So this is going to be the square root of 4 times 66 squared plus 33 squared all over 33 times 2 times 66 all over 33 plus the natural log. All right, plus the natural log of what we have here. We have the square root of 4 times 66 squared plus 33 squared all over 33 plus 2 times 66 over 33 minus, let's do it this way. There we go. Okay, minus, and now we have 4 times 0 plus 33 squared all over 33, so the square root, times 2 times 0 over 33, plus the natural log of 4 times 0 plus 33 squared all over 33, plus 2 times 0 over 33. All right, I'll do the hard one. All right, this one. So 4 times 0 is 0, right? 33 squared over 30, square root of 33 squared is 33, 33 over 33. Oh, but times 0. So that's going to be 0 plus. This is again going to be square root of 33 squared, which is 33, 33 over 33. So that's the natural log of 1 plus 0. Fortunately, the natural log of 1 is 0. Oh boy, now I got to deal with this thing. I really hope that the square root of 4 times 66 squared plus 33 squared is something I can work with. I think it is because it's got a 4 in there. All right, but that's what we have here. If we take the square root of this mess, not something we can work with. Delightful. All right. Well, how about we try this? 66 is really 33 times 2. Okay, so let me just off to the side here. 66 is 33 times 2. Now if I square this, we get 33 squared times 4. And we're going to have plus, right, plus 33 squared. So we have 4 33 squared plus 1 33 squared. This is going to be 5 times 33 squared. All right. So let's just check. We have 5 times 33 squared. What happened? This should have given me something here. Kind of hoping it would give me the same thing that this had. Oh, because there's a 4. No. Oh, there's 4 times 2. Okay. So 66 is equal to 3. Okay, there's an extra 4 here. Okay, there's the 4 we had in the beginning. So this should be 17 times 33 squared. There it goes. Okay, so this is 17 33 squared. Why are you doing that? Because 33, the square root of 33 squared is going to be 33. Okay, so we're going to have this this business in here. This is going to be the square root of 17 times 33 squared all over 33. These guys are going to cancel, so we're just going to have the square root of 17 there. Okay, times, well, 66 over 33, that's 2, so times 4. Okay, so that's times 4. So the beginning part of this thing is going to be 4 root 17. Unfortunately, this whole thing is 0. And then we have the natural log plus the natural log. And the reason why we did that was because I know the same thing is going to happen over here, right? We're going to have the square root of 17 here plus 4. All right. So there we go. Yeah, minus 0. Oh, by the way, the whole thing is times something at the beginning, right? 33/4. Okay. There we go. This would have been your first. If I said just go ahead and take a guess, this would have been the first guess, right? It would have been, of course. So 4 root 17 plus natural log, square root of 17 plus 4. And there's nothing you can do with this. You're just done. Okay, so that's the distance that this whatever the hawk had as its prey, that's the distance that it fell. All right. I have my theories about when cats are knocking stuff off the table. They're really doing all of this, trying to calculate exactly how far something falls. Okay. But there we go. Okay, I'm sure this is a delightful number we can pump into the calculator too. I'll leave as exercise for the reader to appreciate closure here. All right. So aren't you glad you learned chapter 7 as well as you did at this point? You could do all of this. All right. I'll try another one. All right, this is one that's a little bit further up. By the way, would never be a test question. Okay, this is insane as amount of work to do. We are not doing this as a test question. Okay, but now we're going to have y is equal to natural log 1 minus x squared. Okay, and we're going to go from 0 to 1/7. Okay, so very long way here. So you might have something like this, right? The length of a circuit, the length of a wire inside of a circuit. I don't know, but you might get something like that. Okay, so we're going to go from 0 to x equals 1/7. So let's see here. Our y prime is equal to 1 over 1 minus x squared times negative 2x. So that is negative 2x over 1 minus x squared. Okay. But now we need to do y prime squared. So that's going to be 4x squared over 1 minus x squared squared. So what are we integrating? Well, we're integrating 0 to 1 over 7 times the square root 1 plus y prime squared. Well, rather than attempt the triangles one more time, let's see if we can do something better. So all I did is I multiplied this 1 by 1 minus x squared over 1 minus x squared. Let's see what comes of it. Okay, so this is technically still inside of the square root, which is still inside of an integral from 0 to 1/7. All right, well, let's see here. We are going to have 1 minus, right, 2x squared plus an x to the 4th. Is that okay if I multiply that out quickly? Plus a 4x squared all over 1 minus x squared squared. And this is still inside of square root, which is inside of an integral. And now we're ready to go. I've got a negative 2x squared. I should have put the 4 plus a 4x squared here, right? So that's going to be 1 minus 2 plus 4 is plus 2x squared plus x to the 4th over 1 minus x squared squared inside of a square root, inside of an integral, and ready to go. By the way, I love this little trick. The calculus book that I had did this to us all the time. You could factor this. Right? This is 1 plus x squared squared, 1 minus x squared squared inside of a square root, inside of an integral, 0 to 1/7 dx. How do I know x is greater than 0? Because it told me. So we can go ahead and take the square root of the square. So we end up with the integral of 0 to 1/7 of 1 plus x squared over 1 minus x squared dx. I'm going to rewrite this just one little bit. I'm going to say this is x squared plus 1 negative x squared plus 1. Okay. And can we integrate that? Yes, but not the way it looks. You know, everybody loves synthetic or loves polynomial division. I know this is your favorite thing. They have to match. 1 times negative 1 is negative 1. We're going to subtract x squared minus a negative x squared. Right? So that should be positive because negative 1 times negative 1. So x squared minus x squared is 0. And 1 minus a negative 1 is 2. So this integral is really 0 to 1/7. And we have negative 1 plus 2 over 1 minus x squared. I'm going to switch back. Dx. Well, again, isn't it great that we knew chapter 7? So we could say that 2 over 1 minus x squared is equal to a over 1 minus x plus b over 1 plus x because of partial fractions. Right? So here we're going to say that a1 plus x plus b1 minus x is equal to the numerator over here. So my x coefficients, we have a, right, is ax. We're going to have a minus b. How many x coefficients do we have over here? None of them. And we're going to look at our constant coefficients, right? We have an a plus a b. And what do we have over here? 2. Okay. We can add these, right? These are going to cancel. We get 2a equals 2. Ha, a must be 1, which means b is also 1. Okay, so going back up to my original integral here, we've got 0 to 1/7. Okay, we have negative 1, we have plus 1 over 1 minus x plus 1 over, 1 over 1 plus x, all dx. When I do my little u substitution here, we're going to get negative x minus a natural log of 1 minus x. Okay, because there's a du that's negative, that's why we're going to get a negative here, plus natural log of 1 plus x. Okay, all going from 0 to 1/7. Okay, so what are we going to have here? We're going to have natural log of 1 plus a 7th is 8/7. We can just use that. Minus 1 minus a 7th, it's going to be 6/7, right? Minus a 7th. When I plug 0 in here, right, we get 0, get natural log of 1 plus the natural log of 1, 0. Okay, so you remember your rules of logarithms, right? That the log of a over b was equal to the log of a minus the log of b. Well, that works in this direction too. So what we're going to have is the natural log of 8/7 over 6/7 minus 1/7. And you remember how to do this, right? Compound fractions. So we have 7 over 6, 7 over 6. That cancels. So we have the natural log of 8/6 minus 1/7. I cast out a 2. We have the natural log of 4/3 minus 1/7. Okay. And that, right? Now we can plug into a calculator and get an answer for. Okay, but there we go. Okay, again, I'm sure this is a delightful number. Actually, I kind of wonder if it's positive. Natural log of, this is 4/3. Oh, natural log of 4/3 is going to be bigger than 1, and 1/7 is not bigger than 1, so we're okay. Minus 1 divided by 7. And there we go. All right. One more. Okay, promise you one last one. All right. This is my favorite one, by the way. So if you're wondering, like, what can you possibly put on an exam? This is my favorite one. So we have f of x is equal to e to the x plus e to the negative x all over 2. And we would like to figure out between -1 and 1. Okay. Some of you may recognize this as hyperbolic cosine. Okay. And f prime of x, right, is equal to e to the x minus e to the negative x, and all over 2. Some of you might recognize this as hyperbolic sine. Remember, this was the shape of the cable. So now we're going to figure out what the length of that cable is. Okay. This is an even function. I don't know if you remember even functions from pre-calculus, but what we're going to do is we're going to take advantage of the symmetry since it's the same thing on both sides. And we're just going to go twice from 0 to 1. All right, that's what we're going to do when we get set up the integral. Okay, so here we have f prime of x squared. So we have e to the x minus e to the negative x all over 2. E to the x minus e to the negative x all over 2. 2's are going to come out. We're going to call that a quarter. We're going to say e to the x times e to the x, e to the 2x. E to the negative x times e to the x, that is 1. We have 2 of those. Oh, that's going to be a minus, isn't it? Let's go ahead and make that a minus. And then we have e to the x times e to the x, e to the minus 2x. Don't forget the 4. Okay, so our integral, twice from 0 to 1, square root 1 plus, okay, and we're going to say this is 1/4 times e to the 2x minus 2 plus e to the negative 2x on the side of the square root. Okay, so we're going to say this is 4 over 4 plus, actually I'll tell you what we're going to do, is we are going to pull out a 1/4 from both of those. Right, so we're going to figure out, we're going to do 2 from 0 to 1, and we're going to do that, and we're going to have 1/4 times 4 plus. Okay, because all I did was take a quarter out of everybody, so this is my 4/4. So that's why we have a 4 plus e to the 2x minus 2 plus e to the negative 2x. All right, 4 minus 2 is positive 2, isn't it? So here we have 2, 0 to 1, symmetry between -1 to +1. We're just going to have symmetry there. And then we're going to be able to say this is e to the 2x plus 2 plus e to the negative 2x all inside of a square root, inside of my integral, and done. You can factor this. Okay, this is right 2 integral 0 to 1. This is the square root of e to the x plus e to the minus x, right? All over 2 squared. Actually, over 4 because of the 4. And that is going to be, right, 2 integral 0 to 1 e to the x plus e to the negative x. I'll put the 4 out in front. Actually, I'm going to take the square root of that is going to be over 2, isn't it? So we have 2 over 2 here. And then integrate that, we have e to the x. Integrate that, we have minus e to the minus x. And I'll leave the 2 in there. We'll leave it there. Oh, that is integrated. We're done. We have 2 of these going from 0 to 1. We recognize this as the hyperbolic sign. All right. So we have twice the hyperbolic sign. Twice hyperbolic sign going from 0 to 1. And that's it. So this is 2 hyperbolic sign of 1 minus, well, hyperbolic sign of 0 is 0. Okay, because we can plug in 1, 1, and then we'll get that. So here's the lesson. Remember that hyperbolic cosine, right, was the shape of a cable or a rope if we have gravity. Cable, if we have gravity, is the shape of a cable hanging between 2 points. What's the arc length of that cable hanging between 2 points? It's the hyperbolic sign. So the shape is cos x. The length is sin x. Okay, I'm sure that'll never come up on anybody's civil engineering exam or mechanical engineering exam. I'm sure you'll never see this again. Okay, so, but this is one of my favorite problems. So if I have a choice, I'm like, what should I pick for a test question? I love this one. Okay, yes, you have to show me the work of doing it, but you know what the answer is going to be before you get done with the problem. Okay, so if you're going into engineering, you might want to remember this one. It's just really clever. Okay, if you come up with a mechanical or civil engineering project and you're like, oh yeah, the length is going to be hyperbolic sign. I'm like, how'd you know that? It's like, I'm just that good. That's what you tell them. Okay, so that sounds good. I will let you go from here, and then I will see you tomorrow. Okay, stop recording.